Okay, today we're going to look at complex fractions. Complex fractions are basically fractions within fractions. So there's fractions inside of other fractions. So if you are one of those people that doesn't like fractions, I promise your head is not going to explode. We are going to keep your heads firmly attached to your bodies. It will be okay. Because really, complex fractions are not that complex. This complex fraction is x plus 1 over x plus 2. What you really need to remember is that this fraction bar, the big fraction bar, is a division symbol. So this problem is actually x plus 1 over x plus 2 divided by x plus 1 over x plus 5. What do we do for division problems? Yep. Keep the first fraction the same. Change the sign to multiply. Flip the second fraction. Once it's multiplication, it's really just what's on the top versus what's on the bottom. So is there any factor on the top that matches a factor on the bottom that could cancel? X plus 1. So our final answer is x plus 5 over x plus 2. That's pretty easy.
But it's going to get harder.
Hope you can hear that if you're watching the video. I really hope you can hear that. Okay, here's another one. And now as I write it, I'm going to remember what we were doing. So 4y to the third over... Now let's think for a minute. What does 5x squared actually mean? It means 5x times 5x, which would be 25x squared. 5x times 5x. Yeah. 5 squared, x squared. 5x, 5x. 25x squared. Whichever way you get there, that's totally fine. Then... divided by, what is 2y squared? 2y times 2y, or 2 squared y squared, 4y squared over 10x to the third. But we don't divide. We keep the first fraction the same, change the sign to multiply, flip the second fraction. Now we can combine the numerators and combine the denominators. What is 4 times 10? 40. And we've got x to the third on the top, and we've got a y to the third on the top. On the bottom, 25 times 4 is 100. And we've got x squared, y squared. Now we just have to simplify that fraction. 40 over 100, honestly, you can type that into your calculator and let the calculator do the work for you. Or you could divide both of them by 20 to end up with 2 over 5. The x squared on the bottom will cancel out 2 of the 3 x's on the top. So how many x's will be left on the top? 1x. And y squared on the bottom will cancel out 2 of the 3, leaving a y on the top. 2xy over 5. Definitely simpler than what we started with. All right, as we rewrite this, let's do some math in the process. This is a trinomial. What do you suppose we need to do with that trinomial? Factor it. We love factoring. So we are looking for two numbers that multiply to give us 3 and add up to 4. That would be positive 1 and positive 3. And we are dividing this by 2x plus 6. Do 2x and 6 have anything in common? 2. And if we divided both of those by 2, we'd be left with x plus 3. This bottom one isn't a fraction, but to turn it into a fraction, you simply put it over 1. And now we can keep the first fraction the same, change the sign to multiply, flip the second fraction. Once I do that, does anything cancel? So our final answer is going to be x plus 1 on top. And on the bottom, we've got x minus 2 and 2, so 2 in front of the x minus 2. Okay, still pretty easy. Some simple factoring, knowing that division means keep the first the same, change the sign to multiply, flip the second. Easy peasy. This is the second type of complex fraction. This type of complex fraction involves addition or subtraction in the numerator or the denominator. Really, this is a three-part problem. Part 1 is deal with x over 3 plus 2 over 3. Figure out what that's going to be. Part 2, deal with 1 minus 2 over x. Figure out what that denominator is going to be. And then part 3 is going to be to do the division problem. Oops, I should write that down below. Sorry. Okay, so let's start with part 1, the original first numerator. Do x over 3 and 2 over 3 have the same denominator?
Yes.
If they have the same denominator, you can add the tops. That is x plus 2 over 3. So our simplified numerator is x plus 2 over 3. Next, we need to figure out the denominator. 1 minus 2 over x. 2 over x is a fraction with a denominator of x. This first one does not have a denominator of x, so we need to multiply the top and the bottom by x. Now, the denominators are both x, so we can do the subtraction on the top. 1x minus 2 is simply x minus 2. Now we need to do the division. X plus 2 over 3 divided by x minus 2 over x. Some of you might be saying, why didn't you just multiply and flip the second one while you wrote it? You totally can if you can skip that step. So this is x plus 2 over 3 times x over x minus 2. Does anything cancel? Unfortunately, no, nothing cancels. So we have x times x plus 2 on the top. We have 3 times x minus 2 on the bottom. And that is our simplified answer. Although you have to admit that that answer does look simpler than the complex fraction we started with. Okay, I think there's one more example. Okay, step 1 is done. We have 2 over x plus 2. Step 2 is going to require a little bit more work. We have 3 over x plus 2 plus 2 over x. We need common denominators. So, this first denominator has an x plus 2. So this denominator over here needs an x plus 2. And if you multiply an x plus 2 on the bottom, you have to also multiply the x plus 2 on the top. Now they both have a green x plus 2. What does the second denominator have that the first denominator does not? An x. So we need to multiply the top and the bottom by the x. Now the denominators are the same. The denominators are x times x plus 2. So we can distribute and combine the top. We've got 3x plus 2x plus 4. What is 3x plus 2x? 5x. So this is 5x plus 4 over x times x plus 2. Okay, now here's the bad part. That is just the simplified bottom of the original complex fraction. So now we need to do step 3, which is do the division. Or if you want to skip a step, don't divide. Keep the first fraction the same, so 2 over x plus 2. Change the sign to multiply, and what are we going to do to this fraction? Flip it. X times x plus 2 over 5x plus 4. What cancels? So our final answer is 2x over 5x plus 4, and that is certainly a lot simpler than whatever we started with. So step 1 is simplify the top, do whatever needs to be done on the top, factor it, combine it, get the denominators the same so you can add or subtract it. Do the same thing to the bottom. Once you have the top simplified, the bottom simplified, then do the division problem. So simplifying complex fractions are really just doing 3 problems in one. Simplify the top, simplify the bottom, and then do a division problem. Your original assignment sheet had 4 through 14 evens, 24, 26, 30, and 32. That's 10 problems. I have shortened it down to 6 problems. Number 4, 8, 10, 12, 24, and 30. So if you're following along on that assignment sheet, make sure you edit your assignment sheet to match these 6 problems. I mean, if you want to do 4 extra problems, go for it. It's great extra practice, but you don't need to.